There's so many problems with how people are doing evals today. When you think about an environment, it is fundamentally a simulation of a world. So a simulated world needs to have several components, and this is how humans learn, this is how agents learn. You need a way to actually take action and receive feedback.
How do we systematically evaluate and improve increasingly autonomous AI systems? Rebecca Chen is the co-founder and CTO of Patronus AI. A former NLP researcher at Facebook AI, Rebecca and her team are building millions of adaptive simulated environments, or intelligent worlds, that teach AI agents to reason, plan, and make decisions like humans. We'll explore the Eval Problem, the reality of simulations, the stakes of reward hacking, and the factory behind general intelligence. This is the story about a founder who turned years of AI research into a world of its own. Hey there, it's Glenn Solomon, and today on the podcast, I'm excited to have my Notable Capital colleague, Dan Kahana, joining me. Hey, Dan.
Great to be here, Glenn.
We're thrilled to have Rebecca Chen, co-founder and CTO of Patronus AI, with us today. Here at Notable, we were incredibly privileged to lead Patronus' Series A back in 2024. We've been super impressed watching Rebecca and her co-founder Anand and team navigate the rapidly shifting AI landscape. So we're excited to dive into all of this with you today. Rebecca, thanks for joining us.
Of course, I'm excited to dive in too.
You spent years at Facebook AI research, and you were working on fundamental NLP problems. Then the ChatGPT moment happened. And you and your co-founder Anand decided to found Patronus.
That's right.
Was there like an aha moment?
Oh, absolutely. I remember so clearly when ChatGPT was released and everyone was talking to ChatGPT, asking all kinds of questions. And Anand's brother, who was an investment banker at the time, submitted a question that it could not solve. And it was a finance problem. And immediately, Anand and I hopped on a call and we were like, this is it. We felt we were at the cusp of large-scale societal deployment AI, and we saw a future where AI systems would be automating enterprise workflows.
What were the hardest problems you were seeing initially that you and your customers were trying to solve?
Problems that wanted to reason over human workflows, the way that humans would actually reason over documents, make decisions. And it is fundamentally this problem of alignment, which is how do we distill human preferences into AI decision making? Because we were no longer just asking AI systems to generate text, we were actually asking AI agents to make decisions. Because when we think about real world work, it's messy, it's unpredictable, and it involves managing large contexts. That's the kind of work that we want to replicate, and we define intelligence as reasoning over uncertainty across a wide diversity of scenarios, and that's why evals are so important.
Where do you see the disconnect in the market?
There's so many problems with how people are doing evals today, and there is no such thing as too many evals. We need to, on the path to building general intelligence, be running millions of different environments, simulations of reality. We need to be training and evaluating these systems on such rich and diverse scenarios, including scenarios that would be unsafe to experiment with in the real world, in order to actually create systems that we have confidence in deploying and that can actually mimic human reasoning. The way that current industry evals are happening, which is benchmark maxing. We have a benchmark and then leaderboards where people are trying to gamify the leaderboard. The incentive is like completely misaligned with what we actually need for model behavior, because whatever is contained in that leaderboard is such a tiny, tiny fraction of the actual scenarios that real world AI systems encounter day to day.
It seems like, especially over the past 6 to 12 months, simulations, environments, broadly like post-training has become a much bigger buzzword in San Francisco. Could you maybe walk us through sort of why this has taken on so much importance and kind of maybe what simulations actually mean practically and what their role is in kind of this next phase of AGI development?
When you think about an environment, It is fundamentally a simulation of a world. So a simulated world needs to have several components, and this is how humans learn, this is how agents learn. And the components, broadly speaking, being you need a way to actually take action and receive feedback. So I take an action, and then I observe what happened, and that becomes part of the trajectory. And then I can actually score and get some feedback. And so right now, and actually there are some people who think that we live in a simulation, so we could be in a simulation right now. There's a 50-50 chance. But even right now when we're talking, like Glenn just nodded, I'm registering that as positive feedback, right? I can also receive penalties. And so when we go through the world day to day, we get so much rich signal from our environment. And this is just like built into the world naturally, right? I pick up an object, I drop it, I need to change my grasp. And we don't get that naturally. And that's why it's so important to build these simulated worlds, because they allow for experimentation, including safe experimentation over scenarios that might be unsafe to in the real world. And if we want to build general intelligence, we basically need to make sure these systems can reason and think through scenarios under uncertainty. Why this has been a really critical pivot and evolution from static data sets and benchmarks is because, a couple years ago when we saw LLM production systems, mostly single turn systems, there's like largely a lot of classification systems, like relatively simplistic. Now, when you talk to Fortune 100s, there's agents that are taking sequential actions, right? So, now we need to build evaluative worlds that actually allow for this concept of time. Like there is like some temporal aspect to it. You can actually interact with the system and get feedback. And you basically are shifting away from, okay, can I actually classify some kind of input or output to can I actually have AI make decisions that can replicate human reasoning and decision making. We have built our entire careers in evaluation. Like, I have been thinking about evaluation my entire career. It's something that I think is it's very, very important, and actually I think the most important problem for us to solve right now to ensure the path towards safe and aligned AGI. So it was a no-brainer for us to work on simulations and developing environments that allow for interactive, evaluative feedback for training and developing intelligence, because we also see the risks of not doing so. For example, there's a lot of talk about reward hacking right now.
Yep.
And that is equivalent to cheating on an exam. And the scary thing is, when you build a simulated world, what the current predominant architecture, and I would really separate the learning algorithm from the actual simulation environment, because when we say environment, it's not just RL, like this actually extends beyond RL. But currently, predominantly the architecture, the paradigm is GRPO, and also with verifiable rewards, RLVR. And so when you have verifiable rewards, like the system's automatically scoring, say, based on unit tests or some kind of metric, it's very easy to gamify this. Like, because the agent can learn to cheat and produce, tests that like fake passing the test, right? And
Obviously, there's a lot of demand for these products right now. And, the labs have very ambitious roadmaps. How do you guys think about sort of deciding which simulations to prioritize and where best to spend kind of your resources?
it is fundamentally what is actually going to be the most impactful from the real world perspective, which is people who are using agents. When we take a step back and we're able to see the whole landscape, like there's basically patterns that emerge, right? So capabilities, like for example, conflict resolution, that's something that people working in different like service-oriented jobs all have, even if one person might be working at Walmart and another person might be working at a hotel. When we think about what simulations to prioritize, we think, okay, it would be great if the next generation of models could resolve conflicts and save like tens of thousands of hours of time for these people who work at these call centers and just have to spend all their time trying to get to the bottom of like a customer complaint. And that can, and you know, it's not, I think the wrong way to think about this is from like a domain perspective, which is a lot of like human data companies historically been like, oh, we have like networks of like subject matter experts. And so we need like someone at Walmart who understands retail, and we need some hotel receptionists for the hospitality industry. We actually don't think that's the right approach, because we're not going to get to general intelligence by just picking apart like each individual role and domain. Like we actually need to be thinking in terms of generalizations and capabilities. Like Dario actually recently wrote this article, like The Adolescence of Technology. There is this quote where he says like we need to generalize across millions of environments. Because like we are actually currently in the era of there are a few generalist models, right? Like, you know, early 2000s, we had like bespoke models, like every company was training their own models. Right now, it's like we have these generalist models. So the model is not going to be an expert receptionist or an expert, Walmart worker. It needs to actually learn to generalize. So it is much more powerful for us to think about, okay, like we want to learn conflict resolution. So we want to build simulations that solve for that.
You guys are bringing something very unique to the table. What is it, and why are you so good at what you're doing?
So we take a research-backed approach to building simulations. When you have static environments, it tends to saturate, right? And we actually want to make sure we are building simulated worlds that are long-living, that are adaptive. Let's say there were 5 subjects and you didn't do well on chemistry. I'm going to actually give you more chemistry questions. So this is called curriculum learning, and we actually adjust the curriculum. Like we have a difficulty filtering mechanism, and this is just one of many approaches we have to actually building living worlds that are adaptive and that we can extend, so that we actually grow with the model provider, so that when their models are at the next stage, we're there with them.
We're not just teaching first grade, we're going to teach second, third, all the way through PhD
level.
No,
and if you're reward hacking, we can detect that too.
Love it.
I feel like one thing that you guys have pioneered is really not just building the product, but building the factory that creates the product. So I'd love to hear a bit about sort of how you think about the moat that you're building into Patronus, and how you think about kind of the scalability of this platform.
The factory is a good way to put it. So we're focused on building the factory that creates these simulated worlds, as opposed to not just creating these worlds in and of itself. And I think that's really important, because we need millions and millions of these, right? And actually, even the labs that we're working with are telling us like, hey, we actually, we need to move fast, and we don't think it's scalable to do everything with a human either. So I think perspectives have really shifted, and just realizing just the volume, like say for one single trajectory, there can be 1,000 steps. It's very difficult for a human to go and annotate every single span. And actually humans make mistakes too. And actually, there's advantages to doing this with AI systems as well, because there's so many scenarios that we need to create in order to properly simulate every edge case.
If you continue on that trajectory and you're as successful as you and Anand and team want to be, tell us what Patronus looks like a few years down the road, what the world looks like.
We want to environmentalize the world, which looks like every single possible scenario that humans can go through in the world. We want to turn that into environment.
There's a lot of environments then that you're going to have to simulate. That sounds like a a very large opportunity in front of you.
Rebecca, being a founder at all is very difficult. I think being a founder at the cutting edge, where you need to keep up with everything that's happening in AI, is extraordinarily difficult. How do you sort of build the confidence to kind of continue forward and also, ground your decisions at Patronus?
I'm, fundamentally motivated by by understanding intelligence and human intelligence. I think the work that we do at Patronus has a lot of parallels to how I have learned about my brain and the brains of our teammates and customers and just human society, right? And I think that has been super helpful for me in grounding myself in day to day, and it's helped me be more resilient. What makes a good agent for learning is just always being open to receiving information. And with the AI landscape and being a founder, just every single day looks different, right? There's constantly something new that happens. And so that's why the best thing, I think, for any intelligent system is to always default to receiving observations. Like, there is no information that you receive that is actually not useful. And in practice, that means constantly reading up on new literature, running code, reading about what's happening within the company and outside of the company, and really gathering as much intelligence as we can before making decisions. Because ultimately, agents and founders and operators are decision-making machines. And really, the quality of the outcome is just the quality of the decisions. So.
Here at Notable, we're as we mentioned earlier, just incredibly grateful for the work that you, Anand, and team are doing, and really excited about your future. Thank you.
Thank you, Glenn and Dan, for having me.
Yeah, thank you for joining.
Thanks for listening to today's episode. If you enjoyed this conversation and want to stay on top of the latest in AI and the future of intelligent systems, subscribe to Notable Perspectives wherever you listen to podcasts.